Hello everyone, welcome to you all. So guys, in today's session we are going to discuss the GATE 25 electronics and communication paper analysis as well as detailed solution. So you guys can confirm audio and video so that we can start the session. So today is 15th Feb electronics and communication exam just completed now, and we have total number of questions that has been asked in today's exam GATE 25 EC. So total number of MCQs were 39, NAT is 12 and MSQ 14. So these are the data that we received from the student, and we have so many memory based questions also. So we will solve one by one the memory based questions as well. First of all guys, if you are also live, you can just confirm, sir, please send me your offer price of courses. Okay beta, if you are looking for any IMS GATE Academy courses price, the detail is given in description. Definitely you can touch with our student advisory team. Now in the last also I will share you the data. So this is all about approximate data guys, okay, whatever detail, so this is not correct actually. So we are coming to the here, this is all about the previous year data. Now I have one question guys, till meanwhile or other faculties also having some questions, so they will also come one by one. I have one question, and if you are my classroom student in offline online, then this similar type of question, even same as it is question we have solved in the class itself. So if you are our classroom student, then you can, it is a gift for you. So just wait, I will show you the question. And in the classroom only, I have solved this question, and I told in the class that such type of questions can come in the upcoming GATE exam as a MSQ. As a MSQ, because it is a control system question. And what is the question guys? A control system is given to you. So I am making this diagram, plus minus control system diagram is given to you. This is G1. And this is here again feedback loop. This is G2. So this is the plus sign guys, plus sign. Okay. And here we have plus minus sign, I already mentioned. This is a takeoff point, okay, this is summing point, and like that we have the diagram, okay. So examiner asking for it, find its equivalent diagram, find its equivalent. So language can be anything, you can just check, okay, find its equivalent SFG. So we need to comment its equivalent SFG. So option number A is given to us. Option number A is this. This is R. Here we have one node. 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 And here we have the one node output node. Here we have G1 given by the examiner. Here this node coming to this. And this is G2. This is coming to here. This is minus 1. So this is 1. This is first diagram is given to us guys. This is the first diagram given. Yes. Now B, here is also 1. B option given to you, this, and here one node, this which is having G2, this is having branch G1, and this is feedback loop minus 1, this is R, and this is Y, and here is also 1. So whatever options are present, I am just showing you options. So this is output node Y, and here we have coming like this, minus 1 branch. This is your input node R. This is your G of 2. Correct? This is your G1. This is the one, and last option is here. That is nothing but again we have a 2 node. One branch is coming like this, minus 1. One is coming like this, G1. And here is something also one like that options we have. This is R, this is Y. You can check guys if such same as it is question came or not, you can just confirm. Or here I think G2 or whatever, okay. So you can confirm the question if you attended that, if you attempted today's paper You can just confirm this. So guys, what I told in the classes कि while making the SFG diagram from the block diagram, you should always remember कि we can convert each and every take-home point, summing point as a node. But what is important, I told in the classes कि in future definitely there is a scope of MSQ. But why? What is the scope of MSQ? Many students don't know कि when we can merge the summing point and take-home point while making the SFG from the block diagram. So guys, if you know this, then it is a gift for you if you are our classroom student. Now tell me, this is the summing point, this is the take-home point, summing point, take-home point. So I told you as a alphabetically also ST, so ST is valid, but TS, Sachin Tendulkar is okay, but Tendulkar Sachin is not okay here. Why? Because take-home point and summing point we cannot merge. But summing point and take-home points are in the series, then we can merge and we can represent as a one node. But this we cannot merge. I told you to remember this. So now tell me guys, you can check the output also. So here is the two forward path G1 and G2 and only one loop. Only one loop, okay. So tell me, option number A satisfied kya? Option number A, G1, G2. So this is, first of all, each and every take-home point and summing point, if we are making as a node, this is the first option. Option number A is 100% correct only. But where the student will confuse, if you will merge, some student think, sir, is this summing point and this take-home point in between there is one, and here is also between one. So why can't, we can merge this, then we can merge this. We can merge this because summing point coming first and take-home point after that. If it is the order, I did the derivation also in the classroom. So this summing point and this take-home point we can merge, but this take-home point and summing point we cannot merge. If you will merge this, then it will give you invalid loop, which is not possible here. Okay. So it means now option number B. In the option number B, what examiner has did? These two node examiner has merged here, that is okay, sir. But this we cannot merge, so that is why option number B is wrong only. Option number B is for sure wrong only. And if you don't know about this merging concept, you can directly check the transfer function also. What is the transfer function? The transfer function must be the two forward path only, that is G1 and then G2, or upon only one loop gain, that is 1 plus G1. This transfer function must satisfy. But when you will check here, we have the two forward path and we have how many loop gain? This loop gain, this two loop gain it is showing. So it means option wrong. Similarly, option number D also, somewhere like that, you can also check the data. It is a memory based data, so maybe G1 and G2 is here and there, but this is also look like wrong only because it does not satisfy. Now coming to the option number C, when you will check now, so examiner in the option number C, this node and this node, if I will name the node as a X1, X2, X3, X4 and output node Y. In the classroom, I just took these node name X1, X2, X3, X1. After that, I explained my students. So student, you can see here X3, X4 node you can't merge, and here it is not merged. But X4 and Y we can merge even because the output, the difference is one only, and the output node does not make any difference. But input node, that is an important condition for the input node. The input node does not have, or the input node must not have the incoming branch. All the branches must be outgoing from the input node. So that is why here is also outgoing R. But here, so here what you can say that, sir, these two merge but these two not merge. It means the forward path will be G1 and G2 and only one loop gain. Tell me guys, yes or no? I hope this is crystal clear to you. You can just let me know, is this crystal clear to you or not? So I think this option numbers G1, let me check once again. I think option number C is also having some, if it is a option number C also correct now, then there must be a, we cannot merge two node na. So this should not come from here actually, if option number C is correct. You can just confirm the data guys. Otherwise, if it is a MSQ, then it should be like this. You can just confirm the data if you have the data. Because it must satisfy only G1, G2. In the must case, this is the G1 and this is G2. This loop gain is only one possible. Loop gain is only one possible, that is this only. This is the only loop gain possible guys. this loop gain, you can't take this loop gain. It means G2 wala loop gain not possible, sir. It means this option wrong. So this option wrong for sure. And for here, if option must be correct, then it should be like this. If I am making this diagram, you can confirm. If this is the diagram, then this is correct only. If here is G1, sir, here is G1, and here we have one node, here we have one node, and this is connect to like this. This is connecting to like this G2, and this is connecting to like this here, that is -1. -1, and this is output node, or even this is the output node, then also doesn't make any changes, no problem. If this is the question, then only option C correct. If this is the answer, then only option C correct. You can check. You can check, guys, yes or no? Then option number A and C will be same only, I think. Then it is a MCQ question. If these two of so again it depends on the option, which option actually present. If MSQ was there, then again I am telling you all the options must satisfy only two forward path, that is G1 and G2, and only one loop gain, that is plus G1 plus G1. Only one loop gain, that is minus G1, no? So ultimate sign is this. So it means this option are definitely correct, and if it is the question is having MSQ question, then the other options must satisfy only two forward path and one loop gain. Yes or no, guys? If others are course mein kafi. Others is saying okay. So others, first of all tell me ki this question has you attempted this question. This question was MSQ kya? Then which was the other options? Can you please tell me? The other options can be like this. If I will make the options for you, can you please tell me, this was the first option correct? Other options can be like this. Here is node, here also node, here also node. So other options can be like this, sir. Ki here we have R, here we have 1, here we have G1, okay, and here we have 1, and from this node, X2 node, okay. So from here to here, let me take here to here, G2. And from here to here, this one take me -1. So if such options are correct, then this option C is also correct. Then you can check here, this two forward path G1 and G2. Two forward path, first is G1, other is G2, and second one is this is -G. Then only maybe this diagram may be in the D, this diagram may be in the A. The sequence maybe has been changed, but the correct answer like that only. You can please cross check. In simple, what I can say that ki in one diagram maybe X1, X2, X3 all nodes are there, and in one diagram these two node we can merge. It doesn't affect the result. If I will merge these two nodes, it doesn't affect the result. But I cannot merge these two nodes. I cannot merge this node because the direction is not allowed. And I told you the example also, take-off point and summing point, if it is in this order, take-off point, summing point, TS, it is not allowed. How to remember for a long time? You can remember only D wrong, sir. Praful says that. Now beta, how C only D wrong? Then here is, if this is the option, G1, G2, na, then loop gain is -G1 only. This G2 is also loop gain coming. So that is why this option wrong. If options are like that, if options are different, then definitely I don't have exact options, whatever information I received from the student, that only we have made till now. Okay, beta. So meanwhile, I will invite all other faculty experts also. So they are also having some questions of network. Meanwhile, also I will confirm the data, and I will again, if there is I will match with the other students also. If they have shared, they already some of the students shared this data only. So I will check also the options, and I will again update you. Okay. Okay. So you have some questions? Yes, please take.
I have certain questions from analog and EDC. I would like to do those questions. Initially, I want to select analog questions. The circuit from the BJT question was asked like this. The question given like this. There is a transistor and 5K resistor is connected here. This is 5K resistor, 5 kilo ohm. And supply voltage is given here. Supply voltage is given 10 volts. 10 volts. And here emitter resistance is given, RE is given here. RE is given as 3K. This is RE, 3K. This is to be taken as a RC value. This is given RC. The base resistance is connected here. This is RB. The base resistance is given. Is asking to find VCE value. VCE is required, collector to emitter voltage. In the problem, it is given clearly beta equal to 100 it is given. Beta is given 100. And also in the problem, it is given base current. The base current IB. Base current is given as 10 microamperes. 10 microamperes is given. But everybody knows very well, it is collector to base biasing. Collector to base and emitter, feedback is given here now. But anyhow, thereby required VCE value, collector to emitter voltage is required. But how we can get, we need to understand one point. The current passing to the RC is to be taken as a IC or IE. This is nothing but IE. This current is to be taken as a IE, emitter current IE. It is a DC IE. This side base current is possible, this side collector current is possible. This side only IC, this is IC. This is the base current. If it is IE, this current must be IE. This current must be IE here. Just by applying the KVL, we can find required value of VCE. Just apply KVL from top to bottom. Top to bottom, we can apply directly here now. If you applied KVL here, I can note down 10 volts equal to, solution I'm doing here now. 10 volts equal to 5K into IE. 5K into emitter current IE is given. This voltage drop is nothing but VCE. We know very well. Collector to emitter voltage. Drop across this is nothing but 3K into IE. 3K into IE. My aim is to find VCE. You know very well. VCE is required. VCE equal to 10 minus 5K IE, 3K IE is nothing but 8K IE. I can take to left hand side 8K into IE. You know very well, emitter current is unknown here now. But IE we can get in the form of IB. That means IE equal to 1 plus beta times of IB, you know very well. Yes, VCE 1.92. Very good, very good. Exactly given here now. And IE is nothing but 10 minus 8K into IE is nothing but 1 plus beta into IB, we know very well. I can substitute directly. VCE is nothing but 10 minus 8K. 8K is nothing but 10 power 3. 1 plus beta 101. 101 into beta is 100. 100 into 1, 101. IB is nothing but 10 microamperes only now. 10 microamperes only. 10 into 10 power minus 6. That's given now. Use calculator. Finally, you will get VC is nothing but collector to emitter 1.92 volts. Yes, exactly correct. Abhishek, what you are getting is exactly correct here now. 1.92 volts. 1.92 volts possible. There is a solution for this question. Now, I want to give you one more question. How many students are getting this answer? How many number of students are getting this answer? May I know? One student, Abhishek, getting 1.92 volts. What about other students? Yes, I will give one more question here now. One more question is given like this. Is asking to find voltage gain. asking in the problem voltage gain. Voltage gain is nothing but VCE by Vs. Voltage gain V0 by Vs is asking here now. For the BJT here given small signal, but in the small signal amplifier AC analysis, if you applied RPI model, if it is taken by using the RPI model, circuit is given like this. RS is given. This is RS. This is given Vs. Source voltage is given here now. This is nothing but RPI. RPI model. Here connected to the ground. Here there is one current source, dependent source must be here now. This is given beta into IB. Beta into IB. What is IB? IB must be this current, you know very well. This current must be IB. Base current, it depends upon the base current. IC depends upon the base current. And here V0 is taken from here. The load resistance is connected here. RL is connected here. But thereby required V0 by Vs. But how to find V0 here? V0 is nothing but voltage across the load resistance RL. V0 means voltage across RL, you know very well. I can say V0 is nothing but current into resistance. Same current is passing across RL. Beta into IB is passing across RL. But that current is passing in the reverse direction. But load has to receive the current now. But that current is in reverse. That's why we can note down here now with sign minus. Minus beta into IB here. Into what? RL I can write. This is V0 value. There IB is required. IB I can get by applying KVL in this path. In this path. I say Vs is nothing but IB into RS plus base current, same current here, same current is going to flow. IB into RP, IB into RPI here. IB into RPI. The finally IB is nothing but Vs by RS plus RPI I can note down. This is the base current. But this base current I can substitute in this particular equation. But my aim is to find the voltage gain here now. So V0 is nothing but, here I am substituting here now. If I substitute here now, I'll get this value. Understand my point now? I will get this value. I'm completing. Just wait 1 minute. I'll get now. Yes. How we can get here now? V0 is nothing but minus beta into IB. IB is nothing but Vs by RS plus RPI. I can take it here now. RS plus RPI into RL here now. Into RL is required. Thereby required V0 by Vs. Directly you can get V0 by Vs. Voltage gain. V0 by Vs equal to V0 by Vs is nothing but minus beta into RL. Beta into RL by RS plus RPI. RS plus RPI I can note down now. Yes, in that way voltage gain we can determine. We can find voltage gain in this way only now. This is the question also from BJT. Understand now. And one more question I have from the EDC. In the BDC, the question was asked like this here now. One more question he asked like this in EDC. Find Dn. He's asking to find diffusion coefficient, Dn. Coefficient of diffusion or diffusion coefficient we can say. But how we can find this at a room temperature only it is required here now. At 300 Kelvin only now. I say at 300 Kelvin I want Dn value here now. Understand now. Dn is required here now. We know very well Einstein relation we know very well. From the Einstein relation we can calculate Dn value. So we know Einstein relation Dn by mu n equal to thermal equivalent of voltage. The thermal equivalent of voltage can also be taken as a K bar T by Q also allowed. By Q allowed. You know K bar and a Q value. If the temperature is there, what now mostly the temperature is given here now 300 Kelvin only now. But you know very well, directly you no need to substitute here now. Thermal equivalent of voltage at 300 Kelvin, you know very well. We know very well. The VT value at 300 Kelvin is nothing but how much? 0.259. 259 volts possible. All right, 26 millivolts. Approximately 26 millivolts, you know very well. That value we can substitute here now. I can write 26.0259 is possible right now. 0.0259. Is it not? 1, 2, 3. 26 millivolts only now. But here I can write here now, dN is required here now. dN equal to Vt into mu n. The dN equal to Vt is nothing but 0.0259 into mu n is possible here now. Into mu n is possible. That is the value of dN is possible here now. 0.259 instead now. Point 0.025 or 26 millivolts. Please watch it out. 26 millivolts is nothing but 0.26 only. Sorry, 0.26, 1, 2, 3 possible. Sorry, 0.026 only possible. Yes, 0.026 is possible. That much value is possible here. Understand my point now. Followed anybody? Anybody has got any doubt regarding this question? 26 millivolts at 300 Kelvin, you know. That is a 26 millivolts. 26 millivolts equal to what? 0.026. 0.026 or 0.0259 most approximately possible here now. That much value is possible. I hope you followed. So far I have, these are the questions only now.
Hello students, all of you please share your experience regarding GATE 2025 EC paper, how you felt, whether it is easy or moderate or tough. All of you just mention the chart. So now we are going to discuss one GATE question, memory based question, which is asked in today's paper, EC paper, regarding network theory subject. So they have given one network. For that network, we have to find out the Z parameters. Find Z parameters of the following network. I hope all of you might have solved this question correctly. So just cross check, like all of you just mention the chart whether you are able to attempt this question or not. Just mention the chart. So in this particular network, they have given all the resistors are of 2 ohm each. This simple question, I hope many of you might have solved this question correctly. This is a two-port network they have given. For this particular network, you are supposed to calculate the Z parameters. So it is a very simple network. Only here you can observe here, this part of the network, if you observe, it is in the pi shape or pi network. So here if you convert, okay, this pi network into T network, then after that you can easily find the Z parameters for the overall network. It is simple question. So here first of all, whatever here internal network you are having, for that you can apply delta 2 star, or otherwise we can say delta 2. So here delta 2 pi network, okay, all are one and the same. So here you are having whatever the internal network we are having, so for that you can apply, just convert that one into star form or inverted star or Y shape. Okay, so here just observe, you are having 2 ohm, 2 ohm and 2 ohm. Okay, so from here you are getting one resistor, from here you are getting one resistor, from here you are getting one resistor, and here the formula is product by sum, product by sum. So here product means 2 into 2. Okay, just for reference here I am writing, for one case I am writing product by sum. So in this case 2 into 2 divided by sum of the three elements. So that means you are getting 2 plus 2 plus 2. Okay, so you are getting 2 into 2 I am keeping as it is. Denominator you are getting 6. So here 2 3 times. That means you are getting 2 by 3 ohm. It is very simple. You can do the calculation without using pen and paper also. Just for understanding purpose I have written the step. Okay, so here we are getting 2 by 3 units are ohm. Similarly here 2 by 3 ohm. Similarly here 2 by 3 ohm. Okay, now whatever the, see here whatever the part of the network we are having, we are able to convert like this. Okay, now you can keep remaining part of the network as it is. Here you are having 2 ohm resistor. Okay, and here we have to consider this line. Okay, so here you can put the voltage notation V1 and the current is I1. Similarly, you can observe here 2 ohm resistor and voltage V2 and the current I2. Okay. Yes. See, for this particular question, only the tricky part of the question is, or circuit is only this portion. Once if you are able to convert this network in the form of like this, okay, right. So after that, this question is nothing. You can easily solve it. And in fact, in order to convert this network into this network, since they have given all the resistance values are equal, you can get easily the resultant value. Okay, right. So here just observe, these two resistors are connected in series. We can add, so 2 plus 2 by 3. 2 plus 2 by 3 is nothing but 3 2s are 6. 6 plus 2 is 8. So you are getting 8 by 3 ohm. 8 by 3 ohm. Similarly, here also the same calculation. You can solve the moment you got here 8 by 3, 2 plus 2 by 3, here also same, because once again these two resistors are connected in series and in fact the same values. Whatever here you are having exactly same. So the same answer you are going to get 8 by 3 ohm. So now just you can observe here you are having one T network. Okay, so this branch, whatever you are having 8 by 3, for the time being I am labeling as RA. Okay, and here 2 by 3 I am labeling as RB, and here this branch resistance I am labeling as RC. So when we are having a T network, the resistances are RA, RB and RC. That time you can get directly the Z parameters. I hope all of you know the standard formula representation for Z matrix for the given T network, right? So by using that one, directly we can get Z equal to, so the formula is RA plus RB, then RB, then RB, RB plus RC. See, it is very simple. Just to how to add these two, that is the here Z11, then Z1 to Z21 for both whatever the common branch is there, that one RB, and then Z22 is nothing but addition of these two resistances RB plus RC. Okay, right. If you want to write in terms of impedances, then ZA plus ZB, 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 ZB plus ZC like that. But since you are having resistances, accordingly I have represented in the form of resistance notation. That's all. Okay. Now, fine. So just add these two, 8 by 3 plus 2 by 3. 8 by 3 plus 2 by 3. Then here 2 by 3. Here also same 2 by 3. And RB plus RC, you are getting 2 by 3 plus 8 by 3. So this is the easiest question. This is the easiest question. I hope many of you solved this question correctly. So here 8 plus 2, that is nothing but 10 divided by 3. So 2 by 3 and then 2 by 3. Once again 2 plus 8 is 10, 10 by 3. See, here we understanding purpose, we have solved the question completely like by using, like here I have written everything on the board, but this question you can save the time. See, when you are having pi network like this, okay, so when you are having equal resistances, I hope when you use this particular formula, product by sum for ease understanding, you can assume here R, right? So that time this branch impedance or resistance you are getting product by sum, that means R into R divided by R plus R plus R. So that means you are getting R square divided by 3R, that is nothing but R by 3. That's all. The moment if you know R by 3 as the formula, then in one step directly you can write 2 by 3. And then whatever here 2 by 3 and 2, these two are in series, accordingly you are getting 8 by 3. Similarly here also you are getting 8 by 3. Then you are having 2 by 3. So this question without using pen and paper, you can solve it, and wherever required, you can use the pen and paper just for representing the intermediate values. That's all. That much silly question and easy question. I hope many of you solve this question correctly. Just observe here, the moment here you are having 2 by 3, accordingly this diagonal element you are getting same 2 by 3, and here just by observation, since this resistance both are same, definitely here also you are going to get both are same. Okay, and you know regarding two-port network, symmetrical condition, reciprocal condition with respect to Z parameters. So even if you are having that conditions, okay, so the moment you have observed that, just by observation of the given two-port network, when you look at the network from this side and from this side, since the given network is looking like same from any of the port, that means the given two-port network is symmetrical network. With respect to Z parameters, when you are saying it is a symmetrical network, Z11, Z22 both are same. And since in this particular entire network you are having passive elements, resistances, definitely it will satisfy reciprocal network, reciprocal condition. So with the help of that, Z12 and Z21 both are same. That is nothing but whatever the shunt branch or whatever the branch that is common for both the ports, I can say. Okay, right. So as of now, we have received one memory-based question regarding network theory subject. So that question we have discussed, and whatever the other memory-based questions we may receive for other subjects, accordingly our faculties will will solve the questions here. Okay, right. You people also, meanwhile, just mention in the chart whatever the topics related questions came in the chart. You can mention, and whatever with respect to subject-wise, whether which subject you felt easy questions, or with respect to which subject they have given moderate level of questions or tough questions, just you can mention the chart, so that it will be whatever the experience you people have today are having with respect to GATE 25 ECE exam. If you mention the chart, definitely whoever going to watch this particular session later, even for them also it is going to help. Okay, right. So before continuing further questions, I am going to give one important update for all the students. Okay. Yeah, just 1 second. Yeah, students, sorry for the interruption. Okay, so before we are going to discuss one more memory based question, I want to give one important update for all the students. After that, we'll continue further. Yeah. So this is the first important update. I hope many of you by this time might have joined our Telegram channel, but whoever not yet joined, so all of you kindly join our Telegram channel, IMS Gate Academy, and you people can share this valuable information with all of your friends and juniors also. It is free for everyone, right? So in this particular Telegram group, we are going to give whatever the upcoming live classes or live sessions that we are going to conduct in our YouTube channel. Okay, so all the important updates you are getting here, and you are getting the lecture PDFs also. We are going to share in this particular Telegram group. Okay, whenever the classes are happening, right? And you are getting all the important updates related to seminars and webinars, etc. And not only that, you are getting all the important details regarding the PSU job notification. Okay, And not but not the least, on daily basis, our faculties will post the quiz questions. You people can actively participate and you can check your confidence level regarding that particular subject or regarding that particular question, etc. Okay, so in this way, on daily basis, you are getting like something new you are going to learn. And in fact, it is the most interesting thing, what are the questions we are going to post in this particular Telegram group. Okay, right. So next, one more important update, especially this is for whoever targeting for GATE 2026 or 2027. Okay, so for all the students, okay, so I am recommending the students, okay, whoever want to get very good rank in the upcoming years, GATE 2026 or 2027. So you people can enroll at our live online program at our IMS GATE Academy. So this valuable information, all of you can share with your friends and juniors who were targeting for GATE 2026 or 2027. Okay, here like you are getting 800 plus hours of live online classes. Okay, so all our expert faculties, we will be delivering the classes from the basics to the application level, and we are going to cover each and every concept in all the dimensions. Okay, and we are going to discuss variety of questions like easy questions, moderate questions, and tough questions with respect to example questions and GATE questions as well. Okay, right. And in addition to that, we are going to provide exercise book questions, exercise book for every subject you are having, and in that exercise book for every chapter you can find 3 levels of questions like level 1, level 2, level 3. Okay, so whoever want to get very good rank, definitely after attending the classes, okay, you have to practice good number of quality questions. So that is the reason we are providing quality exercise book questions. Okay, definitely you are having like 4,000 plus questions. Okay, after attending the classes, whenever you are completing the respective subject, you people can solve the questions based on your convenience in the first round, and similarly whatever the remaining levels of questions later you can solve. Okay, and in addition to that, we are going to provide 33 years of GATE question bank. Okay, here in this particular GATE question bank, we are providing like for each and every question we have provided the detailed solution, and wherever required our faculties have provided alternate solution. And not only that, even for typical questions our faculties have provided the video solution. So the QR code has mentioned in the solution part, just you have to scan the QR code, the respective video solution will be played. Okay, and one of the important feature at our IMS GATE Academy that we are offering for each and every enrolled student, that is 12 My Plan sessions. Okay, so each and every student, they can get personalized My Plan session, mentoring session with the corresponding mentor. They can get the proper study plan and guidance, and whatever the challenges that they might be facing with respect to their GATE preparation, they can discuss with the mentor, and our faculties will discuss, will give the solution, whatever the challenges they're facing. To overcome that, our faculties will guide the students in the proper way in order to get the success in the best manner. Okay, right. And not only that, we are going to provide various tests like chapter test, subject test, and even subject test also, basic subject test, advanced subject test, and then multi-subject test we are having. And after that, we are having all-day mock tests as well. Altogether, you are going to get 130 plus tests. See, this much is required because whenever you are appearing for the GATE exam, and if you want to get very good rank like PSU job, or if you want to do the masters in top IITs or NITs, definitely you should have the knowledge regarding with respect to your GATE paper. Okay, you should know fundamentals, like whatever the basics are there, you should be fundamentally strong, and how to apply those basics while you are solving the questions. How to apply those basics, that is also most important. And that kind of what I mean to say, that kind of confidence and ability to solve the questions regarding GATE exam point of view, that you can get with the help of our exercise book, and with the help of additional GATE PYQs, and with the help of our test series. Okay, so all these benefits that you are getting, so all of you like share this valuable information. Okay, so whoever interested for enrolling for this live online program, all of you, like those students can contact to any of these 2 numbers, or like, okay, you can contact to any of these 2 numbers. Our education advisors will discuss in detail about regarding the program features, or you can book a free counseling session. Then also our education advisor will guide you properly regarding the GATE preparation. Whatever the features that we are offering, I have discussed in detail. You can get more detail here completely. Okay, right. Yeah, and one more important thing. So here at our IMS GATE Academy, we are providing zero fee program. Okay, so whoever, like suppose whatever the features I have mentioned earlier, if you want to check some of the features like how our product, like with respect to lectures, with respect to, you can observe here, with respect to concept videos, you can check with respect to chapter test, subject test, etc. and even GATE 2024 paper video solution. So you people can get all these for free of cost. Okay, and in fact, in addition to that, you are getting one personalized guidance session also. So all these benefits that you are getting for zero fee, you don't need to pay anything, you are getting. Okay, so yeah, just 1 second. Yeah, all these benefits that you are getting for free of cost. So whoever want to check regarding like how our faculties are going to discuss, okay, how the tests are there, what kind of questions or quality of the questions that we are going to provide, you can see the sample, and even you can attend one my plan session. So after that, you people can get more clarity, and accordingly you people can join at our IMS GATE Academy for the live online program. Okay, right. And one more important update. Okay, so this is the national scholarship test, okay, that we are conducting on 23rd February, okay, in this month on 23rd, right? So all of you can mark this date, and whoever like targeting for GATE 26 or 27, okay, you people can participate in this particular national scholarship test, okay, and you can get the scholarship up to 40% for GATE 2026 and 2027 programs. Okay, the percentage wise, the marks that you got in this particular test, and based on that, how much scholarship accordingly you are going to get. That details also you can see here. And this important, valuable information, all of you can share with your friends and juniors, especially whoever targeting for GATE 2026 or 27 programs. Okay, right. Yeah. So you can observe here at our IMS GATE Academy in the last year, that means GATE 2024 exam, with the help of that, so many students have got very good ranks. Here, for the time being, in one slide, we are showing some of the students. Okay, many more students we are having, like with the help of GATE 2024 result, they have got MTech admission in top institutes of India. And even some of the students joined in the public sector also, you can observe here. So Kishan, he is from ECE branch. He got MTech specialization in IIT Madras. Similarly, Sanjeev Achar, he got in IISc Bangalore. Okay, MTech, right. Then Deepak, he joined in IIT Madras in MTech. And Bhavani, she is from CS. She joined in IIT Bombay for MTech. Similarly, Bharat, he is from ECE. He got the MTech seat in IIT Dharwad. Similarly, you can see all other students. Okay, right. So at least this particular slide is giving lot of motivation for all of you in order to get like, yeah, just yeah, I hope all of you got great insights, whatever the updates I have told. So definitely you people can share all these insights to maximum number of your friends and juniors. Definitely you people are getting more benefits whoever joining at our IMS GATE Academy, right? Okay, so thank you for your patience. Okay, now we are going to discuss one memory based question that we have received regarding EMFT subject. Yeah. This is the question asked from EMFT subject. So in this particular question, they have given Z0 as 50 ohm and ZL as 50 minus J75 ohm, 50 minus J75 ohm, and they have given incident power 10 milliwatts and they are asking the delivered power. How much power is delivered? Okay, so for this particular question, first of all, you can calculate the gamma value. Gamma L equal to ZL minus Z0 divided by ZL plus Z0. Okay, just substitute the values here. 50 minus J75 plus, sorry, minus Z0 is 50, then sum of these two, 50 minus J75 plus 50. Okay, so just observe here 50 is getting cancelled. Okay, here you can add 50s. So from here you are getting minus J75 divided by 50 plus 50 is 100 minus J75. So here you can do simplification. So 25 you can take common from the denominator, then the 25 here 3 times. So you are getting minus 3J divided by 25 4 times minus 25 3 times. Okay, now you can do the simplification. You will be getting, after doing the simplification, like you can multiply and divide with complex conjugate 4 plus 3J divided by, yeah, from here just directly, yeah, you can just calculate the magnitude. Yes. So whatever the values here we are finding the magnitude. So you can put modulus. Yeah, numerator you are getting 3, denominator you are getting square root of 4 square plus 3 square. That means from here you are getting 3 divided by root 16 plus 9 is nothing but root 25. So from there you are getting 5. That's all. Okay, 3 by 5 we got, that is the gamma value magnitude or modulus. 3 by 5 we got. Now we have to calculate the delivered power. Delivered power, the formula is 1 minus magnitude of gamma whole square into incident power. So here magnitude of gamma we got 3 by 5. So you can substitute here whole square into incident power. Incident power given as 10 milliwatt. 10 milliwatt. Now you can do simplification. 5 minus 3 is nothing but 2 divided by 5 whole square into 10 milliwatt. So here you can do simplification. 4 divided by 25 into 10 milliwatt. 10 milliwatt. Okay. So here you can do simplification. 5 5s are 25, 5 2s are 10. So here 5.8 times. So that means you are getting 1.6 milliwatt. Sorry, just 1 second. Yeah, 1.6 milliwatt. Okay, all of you just cross check. Yeah, gamma is 0.6. Yes, correct. Okay, sorry. Yeah, sorry. Yeah, sorry. Here only square is there for gamma. Yeah. So 1 minus 3 by 5 is nothing but 0.6 whole square. So 1 minus 0.36 into 10 milliwatt. So from here you are getting 0.64 into 10 milliwatt. So from here we are getting 6.4 milliwatt. Yeah, I hope all of you got the same answer. Okay, so now we will be discussing further memory based questions regarding GATE 2025 EC paper. So all of you stay tuned. Sir, if slides required, plus symbol.
Plus అది ఇదే ఇది పెట్టేసి నెక్స్ట్ లేకపోతే ఓకే ఓకే But I want to do a few more questions from the analog electronics. Students can understand. One statement question is given like this from the operational amplifier. This is given. Identify correct statement about ideal op amp. For ideal op amp, he says ideal op amp. For ideal op amp, here required. Option A is given infinite gain, infinite R out, infinite R out. Infinite R out is given. Option B, infinite R in. Infinite R in. Option C is given here. Infinite open loop. Infinite open loop. Infinite open loop. Common mode gain. Common mode gain. Common mode gain is given. And option D is given here. Infinite open loop. Infinite open loop. Open loop. Open loop. Differential gain. Differential gain. Anybody can guess which is right here now? This is MSQ question here. Anybody can give answer for this question without my help? It is given ideal op amp. For ideal op amp, output resistance is not infinite. It must be what now? Close to zero only possible. Zero output impedance is possible for ideal op amp, you know very well. But input resistance must be, this is infinite R out is wrong here. Infinite R in, that is right. The ideal op amp can have infinite input impedance only now. Infinite input impedance only. This is right. And infinite open loop common mode gain. Common mode gain cannot be infinite. That is a wrong statement only. Infinite open loop differential gain, 100% correct. Differential gain, you know, AD value is always infinity for ideal op amp. So this is correct. So finally, B and C correct here now. Solution is B and C. B and D are correct. B and D are correct. This is the solution for this question. Next question. The one more question is given like this. Here given operational amplifier, there is an op amp. The V0 is connected here. The positive terminal is connected to ground. The resistor R1 is connected here. One capacitor is connected here. This is given R. This is given 10C. Its value 10C. This is input voltage only. Vi is possible this side. Here given capacitance of capacitor is given 2R. 2R is given here. 2R is given. 2R, try to understand. And resistance is given 0.1 capacitor. 0.1 C is given. Resistance value 0.1 C is given here now. And also in the problem here given, FL is given here. Low cutoff frequency is given here now 1 megahertz. 1 megahertz. And is asking to find high cutoff frequency. What is high cutoff frequency? Is asking to find. When FL is given, we need to find FS. From this circuit, we can get the two cutoff frequencies, low cutoff frequency and high cutoff frequency. Low cutoff frequency is calculated by, FL is calculated by low cutoff frequency, that is nothing but WL is calculated by 1 by, this is R1 value, this is C1 value, this is C2 value, this is R2 value here now. These two values given here now. WL means low cutoff frequency is calculated by 1 by R1 C1. They will apply generally. 1 by R1 C1 means R into 1 by 10 RC I am getting here now. 10 RC value possible, omega L, low cutoff frequency. And what about high cutoff frequency? If I ask 1 by R2 C2 you will use. That is nothing but 1 by 2 into 0.1, 0.2 RC is possible, 0.2 RC, that is nothing but 1 by 0.2 means 5 by RC is possible mostly, 5 by RC, omega H. But FH is required, FL is given, here I say omega L is nothing but 2 pi FL, no doubt, that is equal to 1 by 10 RC. But I want to find here the 1 by 2 pi RC is nothing but 1 by 2 pi RC. 1 by 2 pi RC is nothing but 10 into FL, you know very well. 10 into FL. Low cutoff frequency given 1 mega, 10 into 1, 10 megahertz is possible. 10 into 1 megahertz. 1 megahertz. That is nothing but 10 megahertz I am getting here now. 1 by 2 pi RC is nothing but the 10 megahertz I am getting here now. Here, omega H can also be written as a what? By using the omega H, we can get here now, omega H is 5 by RC, you know very well. FH is nothing, but if you substitute a 2 pi FL, FH value it comes, omega H equal to 2 pi FH only now. Finally, FH value it comes as a omega H by, you will get 2 pi. Omega H by 2 pi is mostly possible. Omega H by 2 pi is possible here now. 2 pi into RC is possible. 2 pi into RC is possible. 2 pi is possible now. Omega H by 2 pi only now. But FH is nothing but high cutoff frequency is omega H 5 by R. 5 by 2 RC. 2 pi RC I can get here now. 2 pi RC I can get here now. 1 by 2 pi RC. But 1 by 2 pi RC equal to 10 megahertz only now. Then I can write FH is nothing but high cutoff frequency F into 5 into 1 by 2 pi RC is nothing but 10 megahertz. The finally FH high cutoff frequency, it comes as a 50 megahertz only now. 50 megahertz is possible. The solution of high cutoff frequency. That way we can calculate only now. Next one. The one more question here given like this. But identify correct statement. Statement identify already given, I think now correct statement is given now. Yes, these two problems only I have it now. Okay.
Hello guys, so I have one questions of control system. Can you please confirm the data first? Okay. So the question says that the open loop transfer function is given to you, that is g of s h of s, that is k into s plus 3 dot s plus 4 upon s plus 1 s plus 2. So this is your g of s h of s given to you. An examiner is asking for the value of k, if point minus 1 plus j exists on root locus. So something like that. We have some questions. Language, you can just cross check, guys. Language, you can please cross check. Yes. So student, whenever such type of question, this is just the root locus question based on the magnitude condition, because we have to find out the gain k, so we have to apply the simple magnitude condition. So what is the magnitude condition says that? Magnitude condition says that mod of GSHS is equal to 1 where the point S equal to minus 1 plus j. So when you will put the value here, the transfer function is k into s plus 3. So I am just slightly substituting the value, guys. So when you will put the value here, you will get k into what? Minus 1 plus j plus 3, again minus 1 plus j plus 4 upon minus 1 plus j plus 1. I hope am I audible, guys? Audio is clear. And again here minus 1 plus j plus 2, and this magnitude should be equal to what? 1. So here you will get k, 3 minus 1, 2. So 2 plus j, 4 minus 1, 3 plus j upon this 1 get cancelled. So here only j left, and 2 minus 1, so it will be 1 plus j. And this magnitude will be equal to 1 only. Is this crystal clear, pyare bachcho? So now finally what you will get? You will get k dot under root of 2 ka whole square what? 4 plus 1 5. 5 dot under root of again 3 ka whole square 9 plus 1 10 upon, here you will get a root of 1 का whole square plus 1 it is root 2 and equal to 1. So guys, you can say that here root 2 and here you can cancel because of root, so 2 5 are 10, so it is again root 5 only left. So ultimate answer is k equal to 1 upon root 5 dot root 5, that is nothing but 1 by 5. So answer should be 0.2. Can you please cross check, guys? Super presentation, sir. Well, thank you so much, beta. Just to reply, guys. Is this was the question asked in the gate? बोलो प्यारे बच्चों. Can you please confirm the data, guys? So, is there any other question? Okay, guys. So we'll just wait for some 1 minute and we'll try to connect our maths and aptitude questions. Okay.
Hello everyone, please confirm. Am I audible and visible both? Yes, it is. Yes, alright guys, so let's start with the questions of engineering mathematics. I'm sure you guys tried the questions. The questions are, I will say, in the engineering mathematics the questions are easy. Okay, yeah, in the general aptitude till now I'm not having lots of the datas. Okay, but let's see. All right, so let's start with the very first question we are having here from the engineering mathematics. The question is very simple. It's talking about these type of questions earlier has been asked in the GATE exam so many times, and the very basic question which we used to discuss in our classroom as an example. So the very first question is, a pot contains, there is a box or pot which contains what? Two red and two blue balls. Okay, we will say, and two balls are drawn from the pot randomly, and two balls drawn randomly without replacement. This is the condition of without replacement. Whenever we are having a case of without replacement, we can do one by one draw, or if you want you can solve using the simple combination also. Yes, so without replacement, what the question is asking, what is the probability of two balls drawn have different color? What is this? Have different color. Okay, let's approach the question, the easier question I will say. So first of all, we can see what is given to us. There is a box or there is a pot in which two red balls and two blue balls are there. So total number of balls are 4. It's talking about when you are drawing the balls, it should be random. It should be different. Okay. So both you need to draw the two balls as well, and both are of the different color. So very simply I can say what is possible. It is possible we can have a red ball in the first draw. Okay, and then you can have it is possible to have red ball or black ball, or it is possible to have black ball or red ball. Even it's talking about first and the second draw, है ना? So if it is possible, you can write down directly here the possible cases. So possible cases, in the first draw I am getting red, and red in the first and blue in the second draw, or it is possible to have blue in the first and red in the second row. This is only possible because you want different distinct balls. So probability of getting red when you are drawing red in the first draw. So total number of balls which are red is 2. Okay, and it is talking about what different now. So total number of balls are 2, 2c1 by 4c1. Okay, 2 total red balls are 2, total balls in the box are 4. While I'm talking about blue balls, so blue are 2 here. Okay, but now the total will be 3 because whatever the ball you earlier draw, you are not replacing it back. So this is 3c1. All right, or means plus simply blue ball when I'm drawing. So this is 2c1 by 4c1, and it is talking about and. So 2c1 by 3c1. All right, simply you can multiply also in both the manner we can solve. So 2 by 4 plus 2 by 3, even 2 by 4 I can 2 by 4 I should write down directly here, 2 by 4 or 1 by 2 into 2 by 3 plus 1 by 2 into 2 by 3. Okay, so which is nothing but 2 and 2 gone. This is 1 by 3 plus 1 by 3, 2 by 3 is your answer if you are having option. 2 by 3 if you are not having any option, then it is 0.66. If this is an NAT, so 0.66. If this is an MCQ, I will say. So the result will be what? Wait a minute, again I am not able to see. Now it's visible. Yes. All right. So let's talk about, this is the first question. Let's go with the second question. Second question is again from the probability, and that is interesting question. If you guys attended my session, then using the trick we can solve that question. That is interesting one. Okay. What the question is saying, two fair dice, two fair dice rolled and random variable is denoted by x. So random variable x denotes, this is interesting, denotes the sum of outcomes on these two dices. Okay, denotes the sum of outcome. These type of question means, I will say ki expect, it's what it is asking, it's asking expected value. Expected value type of question earlier has been asked, but it's not asked till now sum, है ना? So x is not directly 1 2 3 4 5 6, x is here sum of the outcomes on those two dice. Okay, that is interesting. So x denotes the sum of outcomes. Then it's asking then the expected value ex of this x. Okay, expected value of x. So let's solve. This is interesting one. So first of all, na bacho, when we are solving these type of questions, as I'm solving, so whenever we are having the two dice, so sample space we know very well what is 1 1 1 2 1 3 1 4 1 5 1 6. Similarly 2 1 2 2 2 3 2 4 2 5 2 6 and so on. We can go with the 6 1 6 2 6 3 6 4 6 5 6 6. So we know very well कि in these type of cases when we are having two dice, so sample space is 6 square means 36. So directly you can write down कि sample space is 36. But the interesting thing is my question is looking for sum of the outcomes. So x is important here. Let's see how we can solve. So here we can go with the interesting one. If you guys attended my session, so very easily I'm sure you guys can solve this one. So I want to write down here what is this, the trick which we used to discuss. We can go with here the minimum sum on the two dice is 2, maximum sum will be 12, and here we are having 7. So the result, the remaining thing will be 3 4 a1. I should write down 2 is there, so 3 4 5 or 6, then this is 8 9 10 11. Okay, and the favorable outcomes are 1 2 3 4 5 6, again 5 4 3 2 1. So this simply I can write down. I'm looking for what? I'm looking for the variables only now. So x, and I'm writing here px, probability. So we can make the table very easily here. For x and px, we can draw this one. Even I can go with this one as well. Okay. So what we are having here, x and px available. So you can wait a minute. You can go with this x means the sum 2 3 4 5 6. So sum is 2 3 4 5 6 7 8 9 10 11 or 12 is possible. Then it is talking about probability. Probability we know very well. We are having two dice now. So two dice, for two dice total number of outcome will be 36. Probability of getting sum 2 is 1 by 36, 2 by 36, 3 by 36, 4 by 36, right? So I'm writing here this is 1 by 36, 2 by 36 and not 1. Okay, 1 2 2 by 36, 3 by 36, 1 2 3, right? 1 2 3 4. Then that is 4 by 36, 5 by 36, 6 by 36, and again it repeat 5 4 3 2 1. So 5 by 36, 4 by 36, 3 by 36, 2 by 36 or 1 by 36. Okay, your question is asking about expected value ex. which is summation of xi pi. So here x1 p1 plus x2 p2 x3 p3 x4 p4 and so on we need to do simply. So here we can write down the expected value ex is summation of xi pi. So that is x1 p1 plus x2 p2 x3 p3 and so on. The last will be when I am starting from here x1 1 2 3 4 5 6 7 8 9 10 11. So last will be what, x11 or p11. All right, you can put the values and you can solve it. So when we are putting here, the result is, you can see 1 by 36, 1 by 36 is overall we are having. So I can take outside 1 by 36. Other than this, I am having 1 into 2 or 2 into 1, 3 into 2. You can see that the numbers, integers I am multiplying. 3 into 2, 4 into 3, 5 into 4, 6 into 5, 7 into 6, 8 into 5, like this one. So if it is possible, 2 into 1 plus 3 into 2 plus 4 into 3 plus 5 into 4 and so on. If I am writing the last one, which is 11 into 2 or I think 12 into 1. Okay? So we can just add up, and 1 by 36 I think it will give you 252 when you will add. So the final result will be 7. You can see this is 2, 6, 12, okay, 20 and so on. When I will add, so the result will be 256 and the final answer is 252 and the final answer will be 252 by 36, which is 7. Okay? So this is surely an interesting one, I will say. And the next question which we are having, which is an MSQ from the calculus. So this is MSQ from the calculus. This talking about the maxima minima. Let's see. It's talking about for the given function fx, which is 2x cube minus 3x square minus 12x plus 1. Okay? For the given function, it's asking for the given function, choose the correct one or choose the correct options. Okay, options is or are, whatever. Options are interesting. No global maxima. Global maxima is only possible when the interval is there, है ना? Infinite result, but interval is there, close interval or open interval. No global minima, global or absolute minima maxima. It's talking about at x is equals to 2, local maxima exist, and at x is equals to minus 1, local minima exist. Let's see how we can go for the solution. So very easily we can find out the solution. So first of all, let's write down the given function, which we are having fx equals to 2x cube minus 3x square minus 12x plus 1. Is it 1 only? हाँ ठीक है, 1. So f dash x, when we are going, this is 6x square minus 3 into 2, 6x or minus 12. We need to put it equals to 0. Better we can write down 6 common. This is x square minus x or minus 2 equals to 0. When you are solving it, we can just solve this quadratic equation and we can get the results as an x is equals to minus 1 and 2. The points will be minus 1 and 2. Now at these 2 points, what we need to do? Let's find out the double order derivative f double dash x, which is 12x minus 6. Let's go with the f double dash minus 1. Okay, this is the double order derivative. I am checking the value of double order derivative at the available points minus 1 and 2. When I am checking at minus 1, this is negative, means minus 12 or minus 6. My result is negative. My result is negative. It means this is less than 0. Less than 0, it means it is talking about maxima. Okay, maxima is possible. But in the option it is given at x is equals to minus 1, you are having local minima. No, we can say at x is equals to minus 1, we are having here what? Maxima. So option D is incorrect. Okay. Let's check about the second one, f double dash 2. That's clearly giving you 12 into 2, 24. Okay, minus 6. This is a positive value. Positive value means greater than 0. It means this is having minima. So you can say ki at x is equals to 2, you are having what? Minima. But in the option it is talking about at x is equals to 2, we are having local maxima. That is also wrong. So option C and D we can eliminate easily. Now what is available? Available is it's having no global minima, no global maxima. Why? Why it is not having global minima or maxima? Just because बच्चों कि this is a function, ठीक है, in which no interval available, no range is given. Suppose they are talking about कि range is 5 to 7 या whatever we are having the range. So in that range we can identify na maxima or minimum. When I am not having any range, so how I will identify the maxima or global minima? So that's very easily clear कि these two options will be correct, true, okay, and these two options will be false. Simply. ठीक है? So this is an interesting one, I will say. And what is the next? Next question is again in MSQ. All right. Let's go with the next one, which is again in MSQ. MSQ, what it is talking about? We are having for the given matrix. For the given matrix A, okay, matrix is 2, 3, 4, 5. I think 4 cross 4 matrix is given to us. 2, 3, 4, 5, 0, 6, 7, 8, 0, 0 alpha or beta, 0, 0, 0 or gamma. Okay? If rank of the matrix is at least 3, for the matrix A, rank means rank of A, okay, is at least 3. Minimum rank is 3. All right. So then it is asking ki then alpha beta gamma, which relation is true for alpha beta gamma? Okay. So first option is alpha equals to 0, beta and gamma not equals to 0. Second, alpha beta gamma all are equals to 0. Third, alpha not equals to 0, beta and gamma equals to 0. And the last one is alpha and beta, alpha beta gamma all are not equals to 0. Okay, it is asking about for which value, then for which alpha beta gamma which conditions are true. This is talking about like this. For alpha beta gamma which conditions are true. So chalo, let's this is interesting question where we need to go use the options. Why we need to use the option? And this type of question has been asked earlier also in the GATE exam. There I'm sure you guys remember ABC type of question. It's not in the recent one, but in the I will say in the 2006, 7, 8, like in that case it has been asked. So the question was very interesting. ABC, if A equals to B equals to C, if A is not equals to B, is equals to C, like this one. Na? So it's similar to that one. What I can do, I can go with the options. First of all, let's start solving the option A. Option A is saying ki alpha you can put 0, beta gamma you should not put 0. Okay? When beta gamma I am not putting 0, so I will put it equals to any constant, any parameter. Okay? So it will be easy for me. So I am writing the matrix A using the option A, which is alpha 0. Na? So this is 2, 3, 4, 5. You can go with the 0, 6, 7, 8. 0, 6, 7, 8. 0, 0 alpha you can put 0. All right. Beta, let us assume I am putting at the place of beta I am putting P. Okay. 0, this is 0, 0, 0, and at the place of gamma as well I am putting P. This is P, right? I need to check whether the rank is what here. So we can see first of all, bachcho, if I am writing this as an 4 cross 4 matrix, not in the matrix form, if I am writing this as a determinate form, okay, because we used to find out the rank using the determinate. So I can see directly ki 4 cross 4 matrix last two rows are identical. Here last two rows are identical. It means the determinant is beta and gamma is equal already. Hai na? It's given to us beta gamma equal, but it is not equals to 0. So we can see since here last two rows are identical, so determinant will become 0. So clear objection. The very simple rule of determinant we used to discuss ki if in a matrix any two rows, minimum any two rows or columns are identical, so determinant will be 0 every time. So here we can say, I will say ki the 4 cross 4 matrix determinant is 0. Okay? Why? Because last two rows are identical. So 4 cross 4 is 0, then what you need to do? You need to check the 3 cross 3. When you are checking the 3 cross 3 bachon, when you are checking the 3 cross 3, you can see this, the very first minor of 3 cross 3 is giving me nothing but the, this is nothing but the principal, whether what it is, this is 0, alpha is 0 na, haan, theek hai. So when I am checking this, the very first minor is giving me, okay, this is 0. So rank of matrix is less than 4. Less than 4 when I am checking the very first minor, this is giving me the determinant 0. But when I will go for the second minor, you can see this determinant is not equals to 0. So directly you can write down ki rank of the matrix A is less than 4, or you can go with the rank of the matrix A equals to 3. Why? Because this first minor is 0. This is triangular matrix is becoming, but when you are going with this one, you can see this is not equal to 0. Okay? So rank of A equals to 3, this is giving you minimum 3. So yeah, it should be true. When I am checking alpha, beta, gamma, all are 0. Okay? So alpha, beta, gamma, all are 0. Let's put here all are 0. So this is 2, 3, 4, 5. This is 0, 6, 7, 8, 0, 0, 0, 0, 0, 0, 0, 0. Again here, bachcho, last two rows are 0 completely. We know very well ki the determinant of any matrix is 0 again when it is having minimum one row or column is 0. So here the last two rows are 0, so determinant of 4 cross 4 is 0. Okay? Since last two rows are 0, so determinant of 3 cross 3 will be also 0 here. All the minor of 3 cross 3 will be 0. How? You can see the very first minor, then the second minor, or the last minor. So all the minors of 3 cross 3 will be 0 because here last two rows are identical. So this is giving you clearly ki rank of matrix A is whatever it is, but it is less than 2, 3. Rank of matrix A will be less than 2, 3, and your question is asking about ki at least 3 to ho hi ho. So no, that's not working. Okay? When I am checking the third option, alpha is not equals to 0, but beta and gamma is 0. Let's check it out. Alpha is not equals to 0. So the result, this is 2, 3, 4, 5. And I am going with this one 0, 6, 7, 8. Alpha is not equals to 0. Beta, gamma can be 0. So 0, what was this? 0, 0. Suppose I am writing here P, any constant value. And this is 0, 0, 0, 0 or 0. So when this is 0, so you can see ki 4 cross 4 minor or 4 cross 4 value, determinant of this 4 cross 4 is 0. Why 0? Are baba, last row is 0 na. So the determinant is 0. Okay. So when you are checking the second, the 3 cross 3 minor, you can see this is a 3 cross 3 minor, and now we are having a, in this 3 cross 3 minor, this is a triangular matrix. So determinant is 2 into 6 into P. This is 12P. 12P is not equals to 0. Okay? Because P is not equals to 0. So this is not equal to 0, then you will see ki rank of the matrix A will be 3 here. So this is absolutely true. Because my question is asking minimum at least 3. So yes, this will be true. This is true. When we are going with the last one, alpha, beta, gamma, all are not equals to 0. So suppose when we are putting all are not equals to 0, so 2, 3, 4, 5, okay, 0, 6, 7, 8, all are not equals to 0. So this is P or P. All are equal but not equals to 0. Okay, 0, 0, 0 or P. So in this case, I can see again, bachcho. In this case, even if it is possible, you can see this what I'm writing. This is 0, 0, 0. Okay, all right. Okay. So if I'm checking, this is nothing but a triangular matrix. This is a triangular matrix and determinant is not equals to 0, isn't it? Are baba, this is a triangular matrix and determinant value is P square. So this is 12P square. Determinant value is not equals to 0 because it is talking na alpha, beta, gamma. All are not equals to 0. Is it the option? The last option is this one only na, alpha, beta, gamma, correct. Okay? So the rank of the matrix is 4 here. So rank of the matrix is 4. My question is asking ki rank should be minimum 3. So yes, this is satisfying. Minimum 3 means it is possible to have more than 3 as well. So 3 and 4 both are possible. So yes, this is true. So this option as well true. So which are the correct one? The correct answer are A, C and D here. Which are correct? A, C and D, guys. These are the correct options. All right, guys. So this is an interesting one. Now I am having one more question. You guys can confirm about the datas as well. And this is the question, okay, from the differential equation. So let's go with the differential equation question. And I think this is an NAT, numerical answer type. Okay. So this question talking about ki for the given differential equation, for the given differential equation t square y double dash t minus 2t y dash t plus 2 yt equals to 0 with the initial conditions y dash is 0 equals to 1 and y dash 1 equals to minus 1. Find the maximum value. Find the maximum value of the yt over the interval 0 to 1. ठीक है, close interval. So this is again an interesting question we are having. We can say this is the question from the Euler's Cauchy equation or differential equation with variable coefficient, right? Differential equation with variable coefficient. Usually we are having the differential equation. Now it's has been asked these type of questions earlier, but they added this is the new thing, and the equation is mentioned in the t by t form. Always we are having x to derivative. We are having here t in the t derivative form. So it's okay. We can write down. So first of all, I am writing the equation t equals. We can solve it first of all.